Alrighty guys, let's add to our notes today. This is kind of going to be the last section that we do in this chapter, but we're going to do like a little mini chapter at the end of this. So that's why there's like all these extra lines here. Let me move this just a little bit. So last thing we talked about was graphing. Today we're going to talk about solving. So solving with roots and also solving with fractional exponents. So like our exponent over index sort of situation. We got to talk about how to do that. And well, I'm bummed that I skipped 78, but that's okay because like if I look ahead of this, I don't think I want to put anything on 78 because I kind of want all my graphing stuff together and then all the solving stuff together. So we'll do 79 and 80 right here for solving. So when we turn to our graphing page, the last page that we did, we had 77 right here. We're just going to leave 78 blank. And we'll turn the page, we got 79 and 80. Okay, so the reason that I love solving so much is because really when we solve, we always solve the same way. So let's title this Solving with Roots and our fractional exponents. So again, the reason I like solving so much is because we always solve the same way. Sorry, my camera's like way over there. Let's try that. There we go. Hi. So whenever we are solving, we want to be thinking about getting rid of addition and subtraction first, multiplication and division next, exponents, then parentheses. So the exponents part is kind of where we will have something new because we might have a fractional exponent or we kind of have a root, which is sort of like an exponent. And so that's where we need to be thinking about this new thing to get rid of. So usually with solving, always done the same way. There's just usually one little new part that we have to consider. Okay. And so if there is a square root alone, to get rid of it, we're going to square both sides. Or if there's a cube root alone, we will cube both sides. Or if there's a fourth root, then we'll fourth both sides, and so on and so forth. Like, I think that makes sense. If we have a fractional exponent, like a over b alone, then the way we get rid of that, so the reason that these ones work here is because the square root is kind of like to the half power. And if I multiply that by 2, it's 1. And if my exponent's 1, I don't need it. And similarly with the cube root, a cube root is really like a 1/3 power. And so if I put a third up there in the exponent with 1/3, they're like being multiplied together. That's just 1. So I don't need that exponent. So really the way we get rid of an exponent is if I have a over b, I'm going to multiply that by b over a. So reciprocal exponent. And like whatever I do on one side, I got to do on the other. And so yeah, we're just going to try a whole bunch of practice ones now. Hopefully it'll go okay. So example time. Examples. Number 1, let's do x to the 3rd plus 40 equals 25. I mean, it's not really any of those, but I think we could solve it. We get rid of addition and subtraction first, so I want to get x all by itself. We're going to subtract that 40. So we'd have x to the 3rd equals negative 15. And then to get rid of something to the 3rd power, we cube root both sides. That's the opposite of that. So they like cancel each other out. We have just an x. Now over here, I want to think about if I can cube root negative 15. And I mean, I can't right off the bat because there's no cube root of 15. and I can't really break it up because it's just 5 and 3, so I don't have a group of 3 things. This is possible to do, like it will give me a negative decimal, so we're just going to leave it like that. If it was the square root of a negative number, we would say no solution, like we're not dealing with i's right now, so that's fun. So yeah, kind of easy, hopefully. Let's ramp it up a notch. If I had something like x plus 10 to the 5th power equals 32, okay, so we're dealing with these exponents. We always need like our exponent part to be alone before we can deal with it. So addition, subtraction goes, and then my exponent was alone, so I was able to deal with it. My exponent here is alone right now, so to get rid of something to the 5th power, I'd have to like 5th root it. And if I 5th root one side, I have to 5th root the other side. And so we have x plus 10, because like 5th root and to the 5th power just cancel each other out. And the 5th root of 32, so like we want a group of 5 things. I think that might be 2. 2, 2, 2, 2, 2. Yeah, so that's 2. So I subtract my 10, and x is negative 8. And the other great thing about solving is like I can know if I'm right, because if I plug in a negative 8 right here, negative 8 plus 10 is 2. To the 5th power is 32. So it all works out. So those are kind of like easy examples, not really the new things we were talking about. Let's jump into some new stuff. So let's say, for example, we had negative 8 plus the square root of 5x minus 5 equals negative 3. So I need to really isolate my square root so that I can take care of it, because again, got to get rid of addition, subtraction, then multiplication, then I can deal with the exponent. So I need my exponent to be alone before I can deal with it. And I have this plus negative 8 out here. So we're going to add the 8 both sides. So we'll have square root of 5x minus 5 equals 5, lots of 5s. And now that my square root is kind of all by itself over here, the way I get rid of a square root is I square it. If I square one side, I have to square the other. And so they just cancel each other out, and you're left with the 5x minus 5 underneath. Then over here, I can do that, like 5 squared is 25. So I'd add the 5. Now we're just dealing with like a baby linear problem. So 5x equals 30. Divide by 5, and x is 6. And again, I might always want to check that I'm right. So I can plug a 6 here, and we'd have 30 minus 5, which is 25. Square root of that is 5, plus negative 8 is negative 3. Works out. Let's try this weird one. Let's try one with a, 2x plus 12 to the 2/3 power minus 3 equals 13. Okay, so here my exponent is this weird exponent. I still need to get it alone, so I'm going to have to get rid of that minus 3 first. So we'll have 2x plus 12 to the 2/3 power equals 16. And so if I have a fractional power, the way that I get rid of it is by making that power a 1. If I have a power of 1, I don't need it. So I'm just going to multiply this by the reciprocal, so 3 over 2 on both sides, which like 16's exponent was just 1, so now it's just going to be 3 over 2. Because this will cancel out to 1, and so my exponent will be 1. I don't need it. So 2x plus 12. Now over here, I want to see if I can actually do that. So this is when we are evaluating fractional exponents. So we want to remember that the numerator is the exponent, the denominator is the root. So we're taking a square root of 16, which I can, that's 4, and then raising it to the 3rd power, which is 64. So we want to evaluate that if we can. Hopefully we can. And now like that all the crazy exponent stuff is gone, we can just get x alone. Like this is just a linear problem. So subtract 12 2x equals 52, and divide by 2, so x is 26. I like these ones. Okay, let's try a couple more on 79. A little bit harder. Here. Actually, let's try one more that's not so hard, and then we'll try two slightly harder ones. So this one, if I had something like the square root of 4x minus 3 equals the square root of 2x plus 7. If I have multiple square roots, if I'm able to get one on one side and one on the other and there's nothing else, it's actually super easy. We can just like square both sides, or if they're both cube roots, cube root both sides, but they have to be like totally along like this. I mean, really, it makes sense too. Like if I have the square root of something over here, the square root of something over there, I just need those under numbers to be the same. So it's like I can just ignore the square roots. Plus, if I square both sides, they both go away anyway. And so then we'd subtract our 2x, add our 3, and so 2x equals 10, so x is 5. Easy, easy. Where double square roots can get a little bit trickier is if I can't like fully isolate it or isolate them. So if I had like the square root of 5x plus 4 minus the square root of x equals 4. So like I'm looking at this one thinking, oh, I wish I could get one square root on one side, one square root on the other, kind of like I had here. And so I might think about adding that x squared over because it's like I can add it, and so it's addition, not subtraction anymore. Also, like the square root of x is just more simple, and that's kind of the one you want to move. And so then we'd have the square root of 5x plus 4 equals 4 plus the square root of x, which like it's not alone. So it's not going to be quite as easy as this one. But I do still have to square both sides. So like when I square here, that's fine. It'll just go away. But when I square here, I really need to square with parentheses because the square root's not going to simply just go away. I'm really going to have to write it twice and FOIL. So if we FOIL, we'd have 4 times 4, so 16. Outer will be 4x. Inner is also 4x, so 8 root x. And then last will be root x times root x, which is like root x squared, which is just x. So we like kind of got out of our predicament, but we still have a square rooty. So now I feel like I want to get that square rooty alone. So I'm going to get rid of this 16. I'm also going to get rid of that x. And so we'll have 4x minus 12 equals 8 root x. Oof. I got to get rid of that 8, so I just got to divide it. I got to divide it into both of these, so that's kind of a bummer. So we're going to have like half x minus 3 halves equals the square root of x. Oh my word. And now I think we just have to square it to get rid of that. Oh, square it again. And I'm squaring two things, so I'm going to have to FOIL again. This is awful. What was I thinking? And so I'm going to write it twice. So half times half is a fourth. X squared. Here we're going to have negative 3 over 4 and negative 3 over 4. So negative 6 over 4. And then last we'll have positive 9 over 4 equals x. Oh my word, and we're finally to just x lands. No more square roots. Oof. Okay. Okay. I hate all these fractions. As much as I love a fraction, I'm going to multiply everything by 4. because then I won't have to deal with the fraction mess anymore. So then we'll have x squared minus 6x plus 9, because like all the denominator 4's will just go away, equals 4x. And what I'm noticing now is that I don't have any more square roots, but I do have an x squared and an x. And this is like a quadratic. So I'm going to want to make it equal to 0. And so we'll have x squared minus 10x plus 9. And kind of the easiest way to try to solve a quadratic is by factoring. So we FOILed twice. Now we're going to factor and think about what multiplies to 9 and adds to negative 10. I think that's negative 9, negative 1. Oh my word, I didn't think we were going to be able to do it. I got so nervous for a minute. I was getting lost in all the math. And so that means my answers are 9 and 1. Oh my word. And we ended up with 2 answers. Like, that's so strange as well. Like, I wonder if they both work. Okay, let's go up here. So if it's 9, we have 45 plus 4. That's 49, so that's 7. Minus 3. Okay, that's 4, so that checked out. The 9 is good. I wonder about the 1, though. So I plug in a 1. That makes this 9. Square root of that is 3. Minus the square root of 1 is 1. That is not 4. Okay, so that 1 is actually not an answer. Ugh. So that's the other weirdness. If you do get 2 answers like this, they might not even both be answers. My word. I will show you this last one. It's kind of like the 6th one there, but a little bit easier. I just don't want this video to go too long. So let's say we have the square root of 90 minus x equals x. And so again, it's kind of this weirdo situation where I can't get my x's together because one of them is trapped under a root and one of them is not. I really can't do anything until the root is gone, and luckily it's like kind of alone here, so we're going to square both sides. So I'll have 90 minus x equals x squared. And so much quicker this time my roots are gone, but also I'm a quadratic again, but so much quicker than last time. And if I'm a quadratic, I think the way I want to try to solve is by making it equal to 0. So I'm going to add my x over and then subtract my 90 and then try to factor. So it multiplies to negative 90 and adds to 1. I think that'll be 10 and negative 9. And so we'll have x plus 10, x minus 9, meaning that my answers are potentially negative 10 and 9. The negative 10 feels weird to me. I'm going to try that one first. Like if I put a negative 10 here, well, that actually works because that'll change into a positive 100. And square root of that is 10. The 9, however, I wonder if that works. So 90 minus 9 is 81. Square root of that is 9. Oh, they both work. Fun. Oh no, I'm wrong. The negative 10 right here, that was 100. Square root of that is 10, but my answer is negative 10, so that negative 10 actually wasn't an answer. So just 9. I'm glad I double checked that. Wow, wow, wow. All right, hopefully it goes okay, guys.